Hello and welcome to the Daily Space for today. Is it really June 19th? I'm not sure anymore. Hello and welcome to the Daily Space. My name is Dr. Pamela Gay, and I am here to put science in your brains. Today we have some short stories. I think everyone is still recovering from the insanity of last week and enjoying their summers. But spacecraft don't get time off. So our first story comes to us from, well, one of our favorite objects, and that's the little tiny asteroid Bennu. Some of you may have seen in the news that the OSIRIS-REx spacecraft has entered into the lowest orbit ever achieved by a spacecraft. And I want to take a moment to put this in perspective. Currently, the OSIRIS-REx spacecraft is orbiting at a distance of 680 meters above the surface of Bennu. This means that it's at an altitude about half that of what your typical jet flies at. This means when you're flying coast to coast or across the ocean, you are twice as high above our planet as OSIRIS-REx is currently above Bennu. Now, the images that they've released don't allow us to fully glory in the high resolution nature of the images that are currently being downloaded to the mission team. Sorry, still recovering from bronchitis. The images that we're going to get, of which this is a mosaic, are going to allow us to resolve features that are just 1 foot across. This means we'll be able to see the structure and the detail and not just like 4 pixels, which is what we can currently see. We're going to be able to make sense of things that are 1 foot across on the surface of Bennu. This Cheerios box is more than 1 foot across. That's what we're talking, people. We will be able to resolve, not that they're there, we would be able to resolve Cheerio boxes on the surface of Bennu. So that's kind of awesome. And these images, which because they have so much detail, are going to be super hard to get through all of. They're going to be prioritized with the science team first really getting down and examining those images that come from the regions of Bennu that look best for potential soil sample sites. And if you want to help the team out and be part of figuring out what are the best potential places to go grab some soil from Bennu, well, click on over to bennu.cosmoquest.org. We're trying to get through all of our slightly lower resolution images by July 10th so that when we have a good chunk of Bennu imaged at these higher resolutions, we're going to know where to go to follow up to try and find that safe place to grab a sample and the scientifically interesting places to explore. Join us once again at bennu.cosmoquest.org. Now, moving from our nearby solar system out to the farthest corners of our universe, I have a radio image that by itself looks kind of like a really weird looking Mardi Gras mask that's out of focus. This really weird image, this is actually 2 galaxies merging 13 billion years ago. This is a radio image taken by the Atacama Large Millimeter Array that is capturing the photons of light that have been traveling for 13 billion years from this merging system. And this image gives us insight on just how violent and rapidly evolving a place our early universe was. This research was led by Japanese scientist, and here I have to look at the name, Takua Hashimoto. And in this research that was following up on a speck originally discovered in a Hubble Space Telescope image, they were able to resolve these 2 different, well, galaxies in the process of merging. And in this data, they were able to find signals that correspond to the presence of oxygen, carbon, and dust. This is telling us that galaxies and stars evolved rapidly. We're not exactly sure, due to discrepancies in how we measure the expansion of the universe, how old our universe is, but it's somewhere between 13 and 14 billion years old, we think. And that means that these systems and our entire universe had time to go from a single speck, evolving out, generating initial chemicals, a little bit of hydrogen, helium, and trace amounts of lithium and beryllium, evolve out, expand, begin to form structures, form generations of stars that lived and died and created that observed carbon and oxygen. And now these star systems are seen, these galaxies are seen, merging and undergoing star formation at rates that are 100 times greater than what we see in our own Milky Way galaxy. This is kind of amazing and shows us just what science we're capable of from here on the surface of our planet when we use instruments like the Atacama Large Millimeter Array, which is the only single system on the surface of our planet, the only single institutional thing capable of achieving this high of a resolution. To get a more detailed image, we'd have to combine a variety of radio telescopes scattered across the planet. So thank you, Alma. You are doing amazing work. And this starts to give us hints of the kinds of discoveries we can expect to see when and if the James Webb Space Telescope ever launches. Yeah, that's a thing. Okay, moving on. It's a slow news day. As I said, it's summer. The big meeting was over last week. And so since I don't have a lot of news to point you to, I want to direct you over to an opinion piece about Neptune that appeared in Wired magazine today. In this article written by Daniel Oberhaus, it's argued that as we look to the future, as we plan for that future, we need to consider getting a new space probe sent out to this ice giant in the outer solar system. We now know, thanks to Kepler and Kepler-2 data, that ice giants like Neptune and Uranus are the most common kind of planet that we've so far been capable of discovering in other solar systems. By understanding these worlds, we'll better understand so many solar systems beyond our own. But right now, we're relying on data that was returned by the Voyager 2 spacecraft back in 1989 and subsequent images that have been taken by the Hubble Space Telescope. While this data that we have continues to reveal new science, is that really enough? It would be amazing if we could send something out to study this remarkable world that is rich in crazy weather, that once had a giant dark spot bigger than our own planet Earth, and that has a moon, Triton, that we think is a captured Kuiper Belt object. And Triton, for those of you who don't know, is bigger than Pluto and Eris. And it has geysers. This means that Triton was once perhaps the largest object in the Kuiper Belt. Now, to get to Neptune, it's going to require two things other than money. One of those is a whole lot of patience. It takes a whole lot of years to get all the way across our solar system. And the other thing it's going to take is a spacecraft that has a whole lot of energy, because it's going to need to have the velocity to get to this world in a human lifetime and the fuel necessary to change its orbit from one that would carry it out of our solar system to one that places it in orbit around an object that has a lot of gravity, but not necessarily enough to capture a spacecraft. Now, to get there, we're going to need the resolve to fund the kind of project that is neither fast nor cheap, which is kind of the direction that NASA's been going lately. So I'd encourage all of you, read this editorial, think hard about Neptune, and consider, well, asking anyone who will listen, can we please have a mission that goes to an ice giant? And that's all I've got for today. That is today's news, and I will now answer your questions in the chat. While you're typing those in, I'm going to remind you to please at me at CosmoQuestX. And while you're typing those in, I'm also going to remind you that this is a production of the Planetary Science Institute, working in collaboration with Youngstown State University. We are a 501c3 nonprofit, and that means that your donations are tax deductible where the law allows. We are supported thanks to the generous financial contributions of people like you. And if you aren't able to make a donation and this show is important to you, there are other ways that you can help sustain our efforts. And one of those is as simple as sharing out that we do this most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific. That's 6 p.m. London time. Share out our show and build our audience. You never know who's going to show up and be able to make everything easier and more awesome in the future. Now, while this show runs most Mondays through Fridays, we also have the Sunday Science Hour with our own Annie Wilson. You can show up and learn about how it is that the black and white images that come off of spacecraft are transformed into the fabulous color imagery that you see in posters, on t-shirts, and, well, on that NASA calendar that some of you may have hanging on your wall. So now it's time for questions. Let me bring the relevant window over into sight and scroll up and see what there is to find. Thank you all for your patience with our initial technical glitch when we launched the show today. Yes, the question is, Guido, what are you having for dinner? That is always a question. We love all the European folks who are able to tune in while they make their dinner. Yes, Bennu is rocks on boulders. Rocks all the way down. I have a correction coming from DPI 209 who says OSIRIS-REx is at an altitude of 420 meters. Let me fact check that against the article that I was looking at. So what I'm seeing is 690 meters, and I don't know which site is wrong. So let's go with it's really low down and in the lowest altitude that has thus far been achieved. Sorry about the lack of clarity. Sometimes the internet is trickstery. And thank you for the bits, Wayne Johnson. Let me switch views so that I can thank you the best way we know how, which is with cuteness. And I'm going to make it rain for the doggos, or at least the dog. The other one may have wandered off. That is Eddie on screen. And we just lost Neptune. Why did we lose Neptune? Okay, hold on while I clear and fix the screens again. I will be working to install updates. Here's to hoping that updates will fix whatever that glitch is. And thank you, Susie Murph. This container is just about empty. So let me add more. I know. There. All the stuff. Thank you, Susie. Scrolling. Larry is asking, what wavelength about is the radio image of the two galaxies? It's millimeter wavelengths. I'm not entirely sure of which specific millimeter wavelengths they used. Drop me the question in Discord and I'll look it up in the paper. Yes, Sock and Cats. The image that I have up of Neptune is an actual image. It was acquired by the Voyager 2 space probe as it flew past in 1989. So Henny's Vorverp is asking, could we use solar sails? And I'm assuming this is to get to Neptune. Um, you could. The problem is that it would be exceedingly slow, and ideally you want to get there within a single generation so that the scientists who started on the project as graduate students are, well, still alive when we get there. This means that we probably need to use something a little bit zippier in order to make it all the way out. It's also unclear if you'd be able to tack into orbit using strictly solar sails at that distance. You'd probably need to have some other sort of drive as well. So Richard Hendricks is asking if I'm skipping Uranus because of the giggle factor, or is Neptune better placed for gravity assists? It's actually neither of those things. It's because of Triton. Neptune's moon Triton gets us a Kuiper Belt object for free, and that's just an amazing opportunity. And Uranus doesn't have as much cool weather as Neptune, so go Neptune, or go to Neptune, as the case may be. Looking to see what else we have. Hanny is asking, are exo-Neptunes usually found at Neptune distances, or are they closer in? So ice giants like Neptune in other solar systems come at all distances. There's actually a whole lot of objects at kind of Earth-like distances that appear to be Neptune-like. Now, we haven't actually been looking for exoplanets long enough to be able to find any of them at distances like Uranus and Neptune. We need to be watching objects long enough that we see them go twice around their star before we can confirm them. And ideally, we really want them to go around 3 full times. And Neptune's orbit, it's long. Let me get the exact number of years. It is many, I know that. Neptune's orbital period. Yeah, it's 165 years. So we're going to have to be looking at other stars for like 400 years before we're able to find things at Neptune-like distances. It'll take a while. Okay. Oh, it's 42 miles. You're bad. Okay, I have no clue, DPI. I'm going to be confused. 42 miles is, that's 0.42 miles, which is the 690 meters I had, so we were both right, but units. Yes, 0.42 miles and 690 meters is consistent with both of us. Okay. So Keeper of Maps also sent bits. There. Oh, that was a really bad throw. I love how Stella just goes to the far back and stares. So Henny asks, how big would those early galaxies be? Would they be considered dwarf galaxies today? Think Large and Small Magellanic Cloud in terms of structure, but more massive. Yes, our instro is correct in pointing out that Triton, because it's so big, this is the moon of Neptune, allows its gravity to be used to change the orbit of any spacecraft put into orbit around Neptune. This means that you're able to do more science looking at more parts of the world without having to use more fuel, which is always a benefit to everything. Yeah, Eddie tries to catch, and Eddie really can't catch anything. He kind of fails at catching. I think he might be nearsighted. Not entirely sure. Anyways, So I think that is all of the questions for today. Now, to let you in on what's going to be going on the rest of this week. Tomorrow, our own Annie Wilson, Binary Blaze, will be here bringing you all the things. So come back tomorrow at 1 p.m. Eastern, 10 a.m. Pacific. That is 6 p.m. London time. Thursday and Friday, I'm going to be at a citizen science meeting at the Planetary Science Institute where I work out in Tucson, Arizona. I will be trying to live stream from the venue, and we believe that the hotel internet will allow it. This is the current plan. So expect not just the daily space, but also interviews and other updates from across the astronomy and planetary science, citizen science community. We're going to work on having on some of the folks from our good friends at SciStarter and whoever else we can capture with a camera and a microphone. So lots of good things to come. And I will be back here in my attic on Monday and Tuesday. And then I'm heading out to California, where some of you are going to be joining me at Joshua Tree National Park for the All-Stars Star Party. I'm looking forward to seeing so many of you, and we're still waiting to see just what's going to happen with the streams, and you'll have either Annie or I next week. And once again, we are taking the week of the 4th of July off. So thank you all for joining me and being part of our community. I'm in the process of putting together a presentation on all that we do over here at CosmoQuest, and I'm really proud at what I'm seeing and all that you're accomplishing with Bennu Mappers. I will be posting those statistics over in Discord and then putting them together for a blog post. So lots of good things to come. So once again, we are a production of the Planetary Science Institute, working in collaboration with Youngstown State University. I would now roll the credits, except for the credit rolling software is, along with so many other things in my software, saying, no, I require updates and reboots. Update and reboot your computers when they ask you to, folks. Update and reboot your computers. So I'm just going to verbally say thank you to all of our mods. You know who you are. I love you dearly because you keep this a safe and healthy community. And so many thanks to all the folks who pledge over on Patreon, Karen Neerman and Gordon Dewis. I'm looking at you two in particular. Thank you to Wayne Johnson and Keeper of Maps for the bits, and to Susie Murph for resubscribing with your Twitch Prime account 14 months in a row. You guys are what keep us going. We are sustained through your efforts, and if you can't make a financial contribution, please help build our audience. Get the word out. And right now, for the goal of keeping the science going, I am going to raid, I think Bother is currently streaming. Let me see if there's anyone else. I make funny faces that they always manage to capture in the previews to our episodes. So I think we're going to catch Bother. Yeah, so we're going to currently raid Bother and give him a fabulous, I don't know anyone with an English accent sucking cats. I'm going to raid Bother and give him a warm CosmoQuest welcome and light up his chat with rockets and rove on doing the science. Thank you for being here, and wherever you are in the world, have a fabulous morning, evening, or afternoon, and I'll see you on the other side. Bye-bye.